Hello my dear friends, students and viewers. This is Sir Palmath and welcome to my video channel. So today, this is the video lesson for our Mathematics Grade 10, which we are talking about the combination of n objects. Specifically, we are going to evaluate using the combination notation. So, before we begin for this lesson, so here are the learning objectives for today's lesson. First, you will be going to differentiate between the permutation and combination, and you will be able to use the formula for finding the number of combinations of n objects taken r at a time. So these are the only two learning objectives that you need to learn and study for this entire lesson. Today, let us discover something before I introduce to you our entire topic for today. So, consider the given situation. Suppose you will intended to mix two primary colors at the same time, given the different primary colors. So, we have red, yellow, and blue. So, in this case, you will be able to mixing two colors. So, to take two colors at the time without the repetition of the different colors. So if the given condition is if you pick two colors, if order is significant and if order is not significant. So to figure out and to solve this problem, so here is our different solution. So first, if the order is significant, we have the following. So we let n is equal to 3 colors. So out of 3 primary colors, so we have to take 2 colors at the time. So we let r is equal to 2. So if the order is important, so we will use the term permutation. So we need to permutate these different outcomes. If the 3 primary colors, we need to take 2. So we have the permutation of n taken r at the time. So which is equal to, using the formula, n factorial all over the quantity of n minus r factorial. Okay? The next step to do is to substitute the value of n and the value of r. So we have the permutation of 3 taken 2 is equal to 3 factorial all over the quantity of 3 minus 2 factorial. And after that, you will be able to simplify the inside parentheses. So 3 minus 2, so we get 1 factorial. So we have 3 factorial divided by 1 factorial. And then simplify by its the factorial value. So 3 factorial, which is 3 times 2 times 1. And 1 factorial is also equal to 1. And then simplify simultaneously. So 3 times 2 times 1, which is 6, divided by 1, so still 6. So there are 6 possible arrangement of 2 primary colors. There are 6 possible arrangements of 3 different colors. So first we have red and yellow. The first is yellow and the last is red. Third is yellow and blue. The fourth is blue and yellow. The fifth is blue and red, and sixth is red and blue. So we notice that there are different arrangements of 2 primary colors. So these are only a total of 6 possible arrangements of different primary colors. Okay, next, if the order is significant class, so we have the following groups of 2 colors. So first, we have red and yellow, so we combine it all together. So red plus yellow, so it becomes orange. So it's still the same with yellow added by red. So still the result is color orange. Of course, in the second, we added the yellow and blue. So first is yellow and the second is blue. So we have the result of color green. So at the same thing, blue is added by yellow, so still green. So we have another one set of 2 colors. So blue added by red, so which produces color violet. And also with the same manner, red added by blue, still color violet. So by adding two primary colors, so it can produce the new colors. So the combination of two primary colors, it becomes the new color, which is the secondary colors. So we have the orange, the green, and the violet. So there are only 3 out of 6 selections that are observed, because when you're mixing two different primary colors, it produces the new color. So we have the color orange, the color green, and the color violet. So we have produces 3 additional colors out of 6. So in relation to this discovery of our topic for today, so we introduce to you more on combinations. So what is combination? A combination is a selection of R objects taken and objects in which order is not important, meaning to say that it is the selection of selected objects which we need able to take from the whole set of objects if order is not important. So it is the arrangement of R objects taken from N objects where R is less than or equal to N, where N is greater than the value of R or equal to that, in which the order of the objects is not significant. So that is the two definitions related to combination in mathematics. So in combination, it states that if there is a set S with N elements, and if R is non-negative integer which is less than or equal to N, then each subset of X that are containing R distinct elements is what we call a combination of X. So today, let us differentiate between these two different terms, the permutation versus combinations. So we have already discussed earlier on the previous video about the permutation. So again, permutation is an arrangement of objects or events which the order is important or significant. So at the presence of arrangement, so significant, which is their arrangement of objects. While on the other hand, combination is the selection of objects from the whole set of objects which order is not important. So for permutation has a presence of arrangement of objects, while combination is the selection. Still with the permutation, if the order is important, while combination it is not important. Okay, today let us discuss about the combination of N objects, which we are talking about the combination notation. The number of ways of selecting from a set when the order is not important. The number of combinations of N objects taken R at a time is given by the formula. So C of NR, meaning to say the combination of N taken R at a time, so which is expressed in combination notation. So which is equal to the value, which is N factorial all over the quantity of N minus R factorial times R factorial. So that is the formula for combination notation, where the value of N is greater than or equal to R. So this is the same manner for solving for the permutation of N objects. So today, let us discuss on how we'll be going to evaluate combinations using the notation C and R, or the combination of N taken R at the time. So by evaluating these combinations, so I present to you some of these illustrative examples on how we're going to solve and to evaluate the value of the combination using the formula for notation. So here is the first illustrative example. How will you evaluate the following combination notations using the given formula? So we have N factorial all over the quantity of N minus R factorial, R factorial. So for letter A, so evaluate the combination of 7 taken 4 at a time, and letter B, the combination of 10 taken 6 at a time. So to solve this set of problems here in the given illustrative example, here is the solution. So let us start with the solution for illustrative example number 1, letter A. Given that the combination of 7 taken 4 at a time. So we let that where n is greater than the value of r. So we let n, which is greater, which is 7, and r is the least, which is equal to 4. And then we have to follow using the combination notation given the formula. So the combination of n taken r at the time is equal to n factorial over n minus r factorial r factorial. And then substituting the values of n and r. So we have the combination of 7 taken 4 at the time, which is equal to n factorial becomes 7 factorial. N minus r, it becomes 7 minus 4. And r factorial is equal to 4 factorial. After that, simplify the inside parentheses. So it becomes 7 factorial all over 3 factorial times 4 factorial. The next step to do is to expound each of its factorials. But the tips to do in order to us to simplify this combination in the given expression on the right is to, from the larger values, we have to extend up to the lowest possible or the greatest possible factorials on the denominator. So for example, from 7 factorial, so which aim to reach the larger one on the denominator, which is 4 factorial. So from 7 factorial, it becomes 7 times 6 times 5 until 4 factorial. So 4 factorial is on the numerator, same in the denominator. So in order to us to easier to cancel out, then we have to expound 3 factorial. So 3 factorial, it becomes 3 times 2. And we cannot omit 1 as the last factor of the given factorial. So we use the cancellation process to eliminate 4 factorial. And we have the remaining here, which is 7 times 6 times 5 all over 3 times 2. So we have the product of the numerator is 210 and the product of the denominator, which is 6. So we get the quotient of 210 and 6, which is 35. That is the value of combination of 7 taken 4 at the time, and that is our final answer. So let's move on to our next solution, which is on the illustrative example number 1, letter B. How about the given the combination of 10 taken 6 at the time? So we all know that the value of n, which is greater or equal to r. So we let n, which is the larger value, which is equal to 10, and r is equal to 6. So by using the formula at the same manner on the previous example, so we are going to substitute the value of n and r. So it becomes 10 factorial all over 10 minus 6 factorial 6 factorial. And then we get the difference inside the parentheses. So 10 minus 6, so we get 4. So that is 4 factorial. And after that, you have to expound simultaneously, but we have to reach until the largest possible factorial values on the denominator. So instead of from 10 factorial, so become 10 times 9 times 8 times 7 times 6 factorial, which is on the denominator. And then you have to going to cancel out 6 factorial. So remaining factors, which is 10 times 9 times 8 times 7, all over 4 times 3 times 2. So simplify, 10 times 9 times 8 times 7, so we get 5,040. And 4 times 3 times 2, which is 24. So we get the quotient of 5,040 divided by 24, so we get 210. That is the value of combination of 10 taken 6 at the time. And that is the final answer. So my dear friends, students, and viewers, so now you know on how we'll be going to use the given formula on finding the number of combinations of n objects taken r objects. So today, how about you will be going to use the shortcut method instead of using the given formula for combination. So today we'll be going to evaluating combination notations using the shortcut method. Okay, so instead of using the formula, the number of ways of selecting from a set when the order is not important. The number of combination of n objects taken r at the time is given by using an alternative formula. So instead of using the formula for combination notation, so we use the combination of n and r taken at the time which is equal to, it's the permutation of n taken r at the time all over the factorial. So that is the alternative formula for using the shortcut method. Okay, without using the given formula. So this I will introduce to you some of the steps in order to solve using the shortcut method. Okay, so the number of ways of selecting from a set when the order is not important. The number of combinations of n objects taken are at the time is given by using an alternative formula. So instead of using the given formula, so we are using another alternative formula for finding or to evaluate the given combination. So combination of n taken r at the time, which is equal to, it's the permutation. The permutation of n taken r at the time all over r factorial. Where P or permutation of n taken r at the time using the general permutation, as I have already discussed on the previous video. And the given condition that the value of n must be greater than or equal to r. So that is the alternative formula for determining the number of combinations to evaluate using the shortcut method. So let us also to introduce to you some of the illustrative examples on how we'll be able to evaluate combinations using the shortcut method. So I will introduce to you some of our steps to solve this. Consider the given example on how to solve the given mathematical expression from the previous example, number 1, letter A. So to evaluate the given combination of 7 taken 4 at a time. So to evaluate this, so this is the first step to do. So number 1, you will be able to identify the values of n and r. Let n be the larger number limit and r be the smaller number. As I have said, the given condition, the value of n is greater than or equal to r. So we let n is equal to 7 and r is equal to 4. So that is the values of r and n. Okay, step 2. Put a fraction bar on the right side of the mathematical expression using the combination. So we all know that the given mathematical expression, which is already in the form of combination notation. So the combination of 7 taken 4 at the time, which is equal to, on the right side, we need to put fraction bar. And we put the unknown first on what is on the, we need to put on the numerator and on the denominator. So we put a question mark first. The next step to do is to, on the numerator, we'll be able to express it as a permutation of n taken r at a time and express it into factor form. So instead of the given combination of 7 taken 4, we will be going to express into permutations. So combination of 7 taken 4, which is equal to permutation of 7 taken 4 all over blank. So which is evaluating to 7 times 6 times 5 times 4. So we all know that we need to put 4 factors, which is the value of r. So 7, 6, 5, and 4. Okay, the next step to do is to, on the denominator, express it as the factorial of the smaller value r. So we all know that among of these two values, the n and the r, so the smaller value, which is 4. So we get the factorial of 4 on the denominator. So which is 4 times 3 times 2 times 1. So that is the 4 factorial. Okay, and lastly, you will be going to apply cancellation process if needed. And you will be going to simplify the given expression obtained in step number 4. So what are you going to do is to apply cancellation process. So the first need to do to cancel out is 6. So since 6, we need to cancel out is 3 and 2. Okay, why 2 numbers? Because 3 and 2 can be multiplied by 6 or factors of 6. So 3 times 2 is also 6 and cancel is also 6. Also, we cancel out 4 and 4 as well. So the remaining factors in the numerator are 7 times 5. And we need to omit 1 on the denominator, so which cannot be right on the denominator. So 7 times 5, so we get the product which is 35. So now you know, my dear friends and students, on how will you going to evaluate the given combination using the shortcut method. Okay? Let's move on to our third illustrative examples, more on evaluating combination notations. So, how will you evaluate the following? So, letter A, the combination of 9 taken 3 at the time. For letter B, the combination of 7 taken 5 at the time. And for letter C, combination of 5 taken 2 at the time plus the combination of 6 taken 3 at the time minus combination of 7 taken 4 at the time. So to solve this set of problems, in the given illustrative example, here is the solution to the given problem. So let us start with example number 3, letter A. So given that the combination of 9 taken 3 at the time, so we needed to evaluate. So we need to put first the mathematical expression, so combination of 9 taken 3 at the time, and then we follow out. Okay, we need two values of n is 9 and 3. So we need to permutate that the combination of two numbers 9 and 3, which is 9 taken 3. So start with 9 times 8 times 7. So 3 numbers. And then we need to factorialize the smallest value, which is the value of r, it's 3. So 3 factorial becomes 3 times 2 times 1. And then the next process to do is to cancel out the factors on the numerator and the denominator. So let us start with 9. So 9, which could be divided by 3, so which is 3, and cancel 3 as well. So we have 3 on the numerator. And then 8 is divisible by 2. So 8 divided by 2, so we get 4. So cancel out 2. So 7. So 3 times 4 times 7, and we need to omit 1. So we have the combination of 9 taken 3, which is equal to 3 times 4 times 7. And the product of these three numbers, so we obtained 84. And that is the value of the combination of 9 taken 3 at the time using the shortcut method. So how about for example number 3, letter B? Given that the combination of 7 taken 5 at the time. So again, so the steps to do is to determine the value of n and the value of r. So we put the given combination notation on the left side of the equation. And of course, on the numerator, so we need to put 5 numbers which are the value of r is 5. So 7, starting from 7, lower than the value. So 7 times 6 times 5 times 4 times 3. All over the denominator, so we get the factorial of each the value of r. So 5 times 4 times 3 times 2 times 1. Okay? The next step to do is to apply cancellation process. So in order to us to simpler, easier. So we have to cancel out first the 5, the same. We have also the 4, and of course 3. So we need to remain 7 times 6 times 2 times 1. But there's more. So 6 is divisible by 2. So we cancel out 6. And 6 divided by 2, so which is 3. So cancel out 2. So we have the remaining factors. So 7 times 3, so we get 21. So that is the value of combination of 7 taken 5 at the time. Okay? So how about for example number 3, letter C? Given the mathematical expression, the combination of 5 taken 2 at the time, plus the combination of 6 taken 3 at the time, minus combination of 7 taken 4 at the time. So in this mathematical expression, so we need to simplify and we get to evaluate the 3 combinations simultaneously at the same time. So in every combination, let us follow in the usage of the given formula. So we all know that, so combination of 5 taken 2, so we need to take 2 numbers at the same numerator and denominator. So started from 5, the largest number, downwards to 4. And we need to take 2 numbers, so we need to factorize 2 times 1. And then, on the second factor or the second term, so combination of 6 taken 3 at the time, So the value of r is 3. So we need to put 3 numbers on the numerator and the denominator. So we have started from 6 going downward. So 6 times 5 times 4. And we get the factorial of the smallest value, which is 3 times 2 times 1. And then, on the last term, combination of 7 taken 4 at a time. So we have 4 numbers should be put both on the numerator and denominator since the value of r is 4. So becomes starting from the largest value is 7 times 6 times 5 times 4 all over the factorial of the smallest value, which is 4 times 3 times 2 times 1. The next process is we can apply cancellation process each of the terms simultaneously. So on the first term, 4 is divisible by 2, so we can cancel out 4 and 2. So 4 divided by 2 is 2 and cancel out the denominator, which is 2. So we have the remaining factors. So the first term is 5 times 2. Next, on the second term, so since 6 is divisible by 3, so 6 divided by 3 is 2. So cancel out 3. And of course, we also 4 is divisible by 2. So 2 divided by 2, so we get 2. So we have the remaining factors, 2 times 5 times 2 on the second term. On the last term, so the first number should be cancelled out is 6 and 3. So 6 over 3, so we get the 2, of course. Or instead of that, 3, cancel out 3 times 2 because 3 times 2 is the same 6. So 6 is the same to cancel out all. And then we have 4 also. So 4, cancel out 4. So remaining factors is 7 times 5 on the numerator. The process to do is to express the uncancelled factors by getting the product. So we have the remaining factors is 5 times 2, which is 5 times 2. And then the second term is 2 times 5 times 2. So, and that last is 7 times 5 times 1. Okay, the next process to do is to get the product of each term. So 5 times 2, which is equal to 10. 2 times 5 is 10 times 2 is 20. And 7 times 5 equals 35 minus 1 is 35. So that is negative 35. And then we have to combine similar terms or the constants here. So we get the answer. So 10 plus 20 is positive 30 minus 35. So the greater the negative number, so it's the sign still negative. And we get the difference. So 30 minus 35 is negative 5. So, and that is the final answer to the given problem for letter C. So, my dear friends, students, and viewers, so now you know on how we'll be able to evaluate the combination notations using the different formulas. So, we're using the notation formula and it's the shortcut method. And that's all for today's lesson. So, my dear friends, students, and viewers, so thank you very much for watching. So, please like, share, and subscribe here at YouTube at Sir Palma TV. So, thank you very much and God bless us all. See you on the next video.